Welcome back, ladies and gentlemen. We got colloids today and colloidal particles in this video. And what is a colloidal particle, right? Or colloids in general. And it's a dispersion of particles of one substance throughout another. So this is not a solution. It's not homogeneous, heterogeneous. You have two different particles, and we'll talk about the sizes in a second. But here's some examples. And so you could think of gas, like if you have a gas that's kind of like the solvent, the dispersing medium, but it's not the solvent because they're not dissolved. And you have a liquid in a gas, so like fog or mist. That would be an example of a colloidal particle. And you guys have seen this, right? If it's foggy out, you don't turn your brights on because it makes it worse. And we'll talk about that in a second. That's the Tyndall effect. You can also have solid, like smoke in a gas. So solid in a gas, smoke would be an example of that. If you have gas in a liquid, some of you guys make a foam like whipped cream. Some of you guys like whipped cream. All right, meringue, like lemon meringue pie or something like that. All right, liquid and liquid. So you can have two liquids, which make an emulsion. So when you have those liquids mixed, it's an emulsion. Maybe you've seen that before. Mayo is an example. All right, liquid, solid in a liquid. All right, milk, egg, magnesia. That's magnesium. That would be, let's go with MgOH2. That's what, well, we'll just leave it that way. Milk and magnesia is magnesium hydroxide. And then we got gases in a solid, like foams, like polystyrene foam. You got liquid in a solid, like jelly or butter. And then you got solids like alloys, like steel, or some gemstones even. All right, even some glass with metal in it. All right, and so those are colloidal particles. And particle size is a nanometer to a micrometer is what the particle size is. So solutions have particles that are smaller than a nanometer. So when you have small particles smaller than a nanometer, they go into solution. When those particles are bigger, they're called colloidal particles. So it still looks like a solution, but the particles are big, and it'll scatter light. That's the Tyndall effect. That's why the fog, you don't turn your brights on because it's scattered. The particles are too big, and the light bounces off of it. Suspensions are where the particle size is bigger than a micrometer. All right, and so this is just a size range from a nanometer to a micrometer, and that's what these things do. Now, one of the things with colloids, they can be either hydrophobic or hydrophilic. And hydrophilic, water-loving, right? Proteins are an example of this. They dissolve in water. And hydrophobic, which they don't like water. Like oils are an example of this. And so how we get like oils, you get olive oil on your hands. What do? We use soap, right? So hydrophobic colloids can be stabilized in water by surface interactions with ions or polar molecules. And so sodium stearate is a perfect example of this, where you have this carboxylic acid head here. They call it the ionic head, right? You technically Na plus likes this, right? But when this gets into water, this splits off. Sodium goes that way, and sodium stearate goes the other way. And then all this is this long, 17 carbon hydrophobic tail. But like your oils, the oils will intermix here, right? They like this, but this makes it dissolve in water and wash away. That's kind of fun. Now, a lot of soaps now are not the old school soaps. They're detergents, and they're fun. But that's kind of how that works. So that's colloids. Just touch on it. We're not doing much with them in Chem 2, but they exist, and now you know. And if you have any questions, reach out. Otherwise, we'll see you next time, guys. Take care.